All right, thank you. So our next guest is Ellen Vorhees. Ellen is a fellow at the U.S. National Institute of Standards and Technology, NIST, where for most of her time there, she's managed the TREC project. Ellen's received her bachelor's in science from Penn State University. She has a master's and PhD degree from Cornell University. And her talk is about building test sets, is it? Yes.
Thank you. Okay, thanks very much. I'm happy to be here to talk to you today. As I just said, we're going to be talking about building test collections, which is something that I have done in the majority of my career, has been building retrieval test collections during a process at NIST, using at the Text REtrieval Conference. And I gave a talk last year at Haystack on TREC itself. And if you were to go back and look at that talk, you'll see that some of the slides that I'm going to be using today were in that talk too. But that was a conscious decision. Don't fear, this is a different talk. I wanted to make this talk self-contained, and so I'm going to provide some of the same background that I did last year, this year also. And part of that background here is what do we mean by a test collection and why do we care? So if you go and you read the retrieval literature, you'll see that test collections, the use of test collections are sometimes referred to as the Cranfield Paradigm. And it's called the Cranfield Paradigm because Cyril Cleverdon, and that's who this is here. Whoops, I hit the wrong button, sorry. That's Cyril Cleverdon right there. He was a librarian. He was a librarian at the Cranfield Aeronautical College back in the mid-1960s. And he and his colleagues decided that they wanted to test which was the best indexing language to use. Right? At the time, there was a whole, actually very rancorous discussion on what was the best index languages in order to retrieve documents. And so he decided he was going to settle that question once and for all by creating a set of documents and a set of queries that people had at his college had submitted to the library, and they were going to index these different documents by all these different indexing languages, and then they would see which ones were better. And so for those of you who are no longer, or who are not dinosaurs, this is a card catalog, right? That's an index. That's what they were using to index. And this whole idea of a test collection consisting of a set of documents, a set of queries that can be answered by those questions, and then a set of relevance judgments, which are which documents should be retrieved for which queries, right? So Cranfield Paradigm is using these test collections to score retrieval algorithms. So why would you want to use such a beast? Right. The rationale for using test collections is that it's an abstraction that has sufficient fidelity to a real user task to be informative. All right. So now this has some caveats with it. If you want to use your test collection to inform something about your particular use case, then the test collection should at least have some bearing on that use case, right? You don't want to be evaluating your news search engine on highly technical medical documents, probably, right? I mean, that's probably a gap too far. But as long as there's some real representation of the documents and the queries in the test set to your real use case, then it provides sufficient fidelity to compare ranking algorithms, because that's really what Cranfield is addressing. It's how well are these algorithms ranking documents when the goal is to rank relevant documents before non-relevant documents, okay? It's general enough to be widely applicable, right? So any one specific use case that you have, the fact that it's ranking algorithm A can rank relevant documents before ranking algorithm B better is is necessary probably for you, but not sufficient. So whatever your use case is, ranking is a necessary problem, but not a sufficient capability. But the fact that it has the general necessary part of ranking before others means that you now have more power in your tests than you would if you were trying to incorporate all of the details of your particular situation. Right? So you're going to lose some realism because you're abstracting away from some details, but you're going to gain a lot of power in that abstraction. So I've said here, what we're trying to do is compare different ranking algorithms with the idea that each of these ranking algorithms is the output of that. The output that we're trying to test is a ranking of the collection where the systems are putatively ranking relevant documents before non-relevant documents. And just because in the rest of this talk, I'm sure that I will start using trec jargon, I call the output of a retrieval system a run. Okay, so that's the output for a set of different queries of a particular part of the test set. I'll call that a run. And trec makes a distinction between the query, which is what the user actually submits to the retrieval system, and the information need, which is the thing the user is actually trying, the expression of what the user is actually searching for is the information need. The query is the data structure that gets submitted. And in trec, we call that statement of information need the topic. And so you'll hear me frequently refer to topics. And so in your mind, if topic doesn't make sense to you, translate that into query, and we'll do fine. If you have a test collection, right, so you have a set of documents and you have a set of queries, and you have the relevance judgments, then you can compute all sorts of evaluation measures, right? And you can go to town with all sorts of different measures, and each of those measures is going to represent a slightly different use case. But basically, all the retrieval methods come down to the size of this area between these two curves. This green curve is the curve of perfect retrieval, right? So that's at every document that you retrieve, you've retrieved a relevant document, and so that's that straight green line. That's ideal performance. Your retrieval system probably had some mistakes, and so it's close to this red line. And the area between these two curves is an area of poor performance, right? And so you want to minimize the area under that curve. And every measure that you're going to look at in terms at least of the Cranfield stuff is some function of some piece of this area between these two curves. Okay? So, don't need to do that, but anyway. The question now becomes, how do you build these test collections? Right? So I guess I should have said earlier than this, test collections have been shown to be helpful, right? They do increase retrieval technology performance because people can use these test collections in small research loops, right? You can sort of iterate over them, and it does improve the state of the art in ranking, assuming that the test collection is actually any good, right? You need quality test collections in order to actually drive the state of the art in effectiveness. And we at NIST and in other similar places which are trying to build test collections for community use are interested in building test collections that are general purpose, which means that they are relatively broadly applicable, and you can use them with a lot of different measures, because then if that's true, if they're general purpose, they're more useful. And you have amortized your cost of building it because more people will use it. You want it to be reusable, and for the purposes of this talk, reusable means that you would get the same score, or at least close to the same score, for a retrieval system that did not participate in the building of the collection as a one who did, as a run that did participate in the collection building, right? So that we're not favoring those runs that were part of the building process. And I should say here also that for the purposes of this talk, bias will mean you're getting the same score either whether the run was part of the building process or not part of the building process. You would get the same score as if the entire document collection were judged. Okay, so we want unbiased, meaning that we're getting the same score as if the entire collection was judged. We want it to be reusable, which means it's fair for those runs that did not participate in the collection building. And we have to do that at acceptable cost. And that's the kicker, right? Or at least it's one of the kickers. Because cost here, again, for the purposes of this talk, cost is going to be proportional to the number of human judgments that we need. Because while there are other costs, they're all dominated by the cost of getting human relevance judgments. So, what do we do? Well, that's where Trec came in. Trec is a project that started back in 1992. And it was the first large-scale implementation of a process called pooling, and pooling is important for the rest of the talk, so I'll have a slide later on talking in more detail about pooling. But Trec was the place where we premiered the use of pooling. We've built hundreds of collections at this point, and for a wide variety of different retrieval tasks, and all of the collections, well, not strictly all of the collections in which we have the intellectual property to distribute can be found in the data section at the Trec website, which is trec.nist.gov. Yeah, sorry. Okay. So the idea behind pooling was the realization that if we wanted a large enough document set to be realistic, right, which we did, we wanted test collections that were large enough for people who were running operational retrieval systems, and at the time, actually, the operational retrieval systems were people like LexisNexis or Westlaw or the National Library of Medicine, right? If we wanted those people to pay attention to what the research community was doing, we had to show that their techniques were applicable to the size that those operational systems required. But we couldn't possibly judge every document in a test collection that was any size at all, frankly, right? So the largest one that I know of at the time, pre-Trec, that had full judgments was a collection of about 1,400 documents. No, that's true. That's not true. It's 12,000 documents. There was an InSpec collection that had like 12,000 documents. And it at least purported to have full judgments for a set of, I don't know, 60-ish queries on that set of documents. And that was ridiculously large at the time in terms of getting human judgments, but it was ridiculously small in terms of people paying any attention to results on it. And so there was this question now of, okay, if we want to build large collections, but we can't judge the whole thing, what do we do? And the answer to that, and this was suggested in a paper in the mid-'70s by Karen Spark-Jones and Keith Van Rijsbergen, we use pooling. And pooling it is based on this observation that if you have a bunch of different retrieval systems, all of which are trying to retrieve the relevant documents at the tops of their ranks, you take the first some number, and here, oh darn, sorry. You take the first lambda for level, documents from each of these runs, and you put them in a set. That set is the pool, and you show just the pool to the relevance assessors, okay? And the idea here is that we're going to only look at the top results because that's where most of the relevant documents should have ended up. And we're going to assume, without any further justification, that any unjudged, because it wasn't seen, any unjudged document is not relevant. So when we compute our scores, if it wasn't looked at, it's going to be assumed to be not relevant, okay? And there were tests done early on with the test collections that showed, by and large, to the best that we could tell, yes, indeed, this was process, the retrieval systems were good enough, and the types of topics that were used and the document collections we used were small enough and clumpy enough that this did indeed produce collections which were fair and reusable. Okay? And this is a new slide. So, this is a slide, so Jimmy Lin and I and Ian Soberoff, who's also at NIST, just this past year, took the Trek 8 collection. So this was a collection that was built in 1999. It's mostly newswire. There's some Federal Register documents thrown into. And we chose this collection because this is a collection which was the most deeply judged, and there's been lots of research on how good this collection is. And to the best that we can tell, it's a really good collection. And we said, okay, fine, what we're going to do is we're going to show now that this really is reusable, because we're going to take results that were never possibly thought of back in 1999, and we're going to create those runs, and now we're going to evaluate those new runs. These were 2021 runs, and so of course they were neural, right? So we've got some transformer runs, and we've got a BM25 re-ranking thrown in there too. So these 5 runs were created by Jimmy Lin at Waterloo, and we took those runs. We created new pools because we wanted to see whether or not, in fact, those unjudged documents that those runs retrieved, and they did retrieve some unjudged documents, were they in fact not relevant? However, if you do that, right, if you just take a set of 5 runs and you look only at the documents that those runs retrieved, you've got other bias problems, right? Now you're focusing on runs for which they're getting scrutiny that they wouldn't otherwise have gotten. And so we said, okay, we won't do that either. We're going to take there were runs that were submitted back in 1999 that weren't judged because we didn't have the budget to do so at the time. So we're going to take the unjudged documents from 1999 plus these new 5 runs. We're going to create depth 50 pools from that set of runs. And now we're going to evaluate all of the Trek 8 runs plus these new 5 ones against this new set of combined judgments. And we're going to compute the rank correlation between how these new runs evaluate and among all the set of runs. And that's what this graph over here is. These are Kendall-Tau correlations. And this line, this diagonal line is the line that, the x-axis is the mean average precision that resulted if you use the original judgments. The y-axis is the mean average precision if you used the new judgments, and you'll see that pretty much everything just lies right on that line, right? So yes, the collections are reusable, and you get a Kendall-Tau, which is a measure of correlation between the ranking produced by the 2 different sets of relevance judgments of 0.9933. And that is far, far, far within the noise of a retrieval judgment, right? You get bigger changes in the correlations of runs if you change relevance judgers, right? If you change your assessors, you change your human assessors, you're going to get bigger changes than we do here. Okay, so that was good news. We've shown that, in fact, yes, the Trek 8 at least is reusable. But you could say, but wait, I have another run, right? My run is better than these runs, I'm sure of it. And I might have more unjudged documents. And so you haven't proved to me that my new run is going to be fairly judged. And what I'm going to tell you is, yes, that's true. I can't prove to you that your run will be completely judged. And I wouldn't be able to do that unless I judged the entire collection. But it's incredibly unlikely that you're going to produce a run that evaluates significantly differently, because not only would your new run have to retrieve many unjudged relevant documents, but in order to make a difference in the scores, your run would also have to rank your new unjudged relevant higher than the already existing relevant, or else again the scores won't change. And that's just vanishingly unlikely, that you would find some method which would organically know just which ones to rank first, right? And so I'm claiming, I've claimed this before, but now I'm claiming it again with more emphasis, that the Trec.8 collection is an incredibly reusable and incredibly reliable collection, okay? One thing I skipped over here, this graph is just showing that not only were the average scores a high correlation, but even individual topics are highly correlated with one another. And if you've done much information retrieval research, you know that nothing happens for all topics, right? It's really, really unlikely to find something that happens for all topics. But in this case, even each individual topic has a high correlation with the two different relevance judgments. And the one case where it didn't happen, it's just because the scores are so low that the infinitesimal change in score causes a huge change in ranking, okay? All right, so good news. That happens, that's true. But Trec.8 is a special case in that, well, I mean, it's not a special case, but it is a case in which we judge comparatively many documents for the size of the collection, or for the size of the document set. And if you think about the idea behind pooling, you know that as your document set gets bigger, at some point, this idea that you have found most of the relevant documents in the top little constant lambda is going to become false. We don't know particularly when that point is, but we do know that it has to happen. And there's been a lot of earlier research that shows in particular pooling works because when you have a small collection and a deep enough pool, you find a good sample of the relevant, right? So you get past this swell of documents that are relevant because they happen to match a query word, right? That's the query words are the easiest. Documents that contain query words that are relevant are the easiest relevant to retrieve. And if your lambda is deep enough, then you'll get past that swell and you'll get into other types of relevant, right? If your document collection is too big and your lambda is too small, you'll stay within that early swell and you won't get your other sets of relevant. And we had an example and where we could see this happening in practice in one of the Trec collections, and it wasn't even all that big of a document set. It's just that the number of relevant was big enough that we never got past that. And this one run, it was a smart run out of Sabre Research, which was out of Cornell, showed that I did essentially a feedback algorithm based on previous judgments and retrieved some really unique documents, which when the human looked at them, they said, yes, they are relevant, but none of the other systems had retrieved them, and they didn't have query words that matched. And that's how we found the original problem of breaking pooling. And so we had to do other things. And then there was a variety of research that has happened to do these other things. Some of one was to introduce new measures. So these are measures no longer make the assumption that any unjudged document is not relevant. It's an unjudged document is just an unjudged document, and you sort of ignore it. So those are compressed measures do that. bpref does that. Or you pick the particular way that you're going to sample from these runs in order to be able to make probabilistic statements about the relevance of those unjudged documents. And that's what the inferred measures that came out of Northeastern University did. So inferred NDCG or inferred precision or inferred map. And at the leftmost scheme thing there is an idolation of what happens when you're choosing the strata for which you're going to compute these inferred measures. The problem with these inferred measures is one, they're not general purpose. You have to know beforehand that that's what measures you're going to use and that's how you're going to build the collection, which you can do certainly. But the quality of those estimates of relevance, the value of these measures, is highly dependent on how you choose your sampling strategy. So you have to know what you're doing there too. But that's possible. Another reaction to how do we choose these documents to judge more sensibly was, well, okay, instead of choosing the top 100 documents from every run, let's be a little bit more intelligent about how we're doing that, and we'll apply a bandit method, right? So a multi-arm bandit method that if some run is giving me lots of relevant documents, I'll keep taking documents from that run to judge, and I'll switch to some other run when it gives me a non-relevant document, right? And you can produce a set of judgments there that contain more relevant documents for smaller numbers of judgments than in pooling. The problem there is that if it happens to be the case that your budget is small compared to the number of relevant documents, and remember, you don't know how many relevant documents there are because that's what you're trying to find, but if it ends up being that your budget was small compared to the number of relevant judgments, then this process isn't even fair, because a run with lots of relevance starves out all the rest of all the other runs, okay? And so if you happen to be the lucky run that I picked first, and I run down and I find all of your relevant documents, it means all these documents over there in Nate's run don't even get looked at. Even though they were relevant, they don't get looked at because I've exceeded my budget, okay? And the not fair part is really, really hard to explain to Trek participants, right? And so we don't do that anymore. We did try that. And in fact, all the collections that we built using the multi-arm bandit methods, we had a budget that was big enough so that they were fair, but we can't guarantee that, and we can only tell that retrospectively. So we went to a different process, which is called continuous active learning, or CAL. And I'm going to talk more about CAL because it's in the next part of my talk a little bit later. But here, basically, this is, okay, we're going to start with tiny pools and just get enough judgments to hand off to some sort of learned model. In fact, I'm pretty sure CAL uses regression. And then we're going to let that model tell us which documents to judge first. So we're going to ignore the runs after we do the first top pooling. And we're going to build collections using that way, which also gives us more judgments for fewer than pooling would do. But I had this on my slide, but I never said it in person, and I want to stress it. Remember here that our goal is not to find the absolute most number of relevant documents. Our goal is to find the biggest set of fair set of relevant judgments, right? We don't want a biased set of relevance judgments, because a biased set is actually worse than a smaller set that's fair. It is considerably worse for the purposes of judging. So this brings us to the deep learning track it happened in 2019 to 2021, and it's happening again this year. The deep learning track in Trek is sort of a mashup between the MS Marco leaderboard and a Trek track. And how this is working is the end result of the track is a traditional Trek collection in terms of we end up with a collection of fairly deep judgments for a fairly small number of topics, right? So it's about 50 topics, and the judgments, you get couple, so say 500 judgments per query. Whereas on the other hand, the MS Marco data set, which can be used for training, and that's why it's the deep learning, is because there's enough data here to train these models, is the hypothesis at least. The MS Marco data, there's hundreds of thousands of queries, but each of them has basically one judgment. So a judgment of one relevant document, okay? So different sorts of judgments, budgets spent in different ways here. And within the track, we're using NDCG at 10 as the primary measure. So here we are back at Cal again, and as I said earlier, what this process was is you formed top 10 pools in this case. So lambda was 10. We used that to seed the model building. So for each topic, you create a top 10 pool over the whole set of runs, use that set of documents to create a model, have that model pick which documents should be judged next, and you get human judgments, and you stop that process until either you run out of budget or you haven't found enough relevant documents for long enough that you think you've probably found them all, or you have found so many relevant documents that you stop the topic and you throw it out because you know you aren't possibly going to get enough judgments to be a fair set, okay? And this process resulted in fair collections, to the best that we can tell, reusable collections, the best we can tell, in 2019 and in 2020. But things went haywire in 2021. And what happened was the document set got much larger in 2021. For the passages corpus, it was like, what did I say up there? 18 times? No, 15 times the size of previous ones. Document corpus was only about 3-4 times as much previously. But this results in what I'm calling here too many relevant documents. And I have too many in square quotes there because, right, relevant documents are relevant documents and there aren't too many. There are however many there are. But for the purposes of evaluating retrieval systems and being able to distinguish among retrieval systems, there are so many relevant documents in these collections that all of the systems, no, not all of the non-broken systems that participated in Trek 2021 were easily able to find 10 relevant documents in the top 10. And that makes it really hard to try and distinguish systems, right? And if you try to do deeper measures, which is the rational response to trying to do saturated measures, we don't have enough judgments. There are too many unjudged documents to be able to have reliable, deep measures on these runs. Here's just precision at 10 on the left, NDCG at 10 on the right. These are box and whisker plots. So the x-axis here are different topics. The distribution is the score among the set of runs that were submitted to Trek in 2021 for that task. The bar in the box and whisker plot is at the median. And look at all these topics whose median score is at 1, which is the top score, right? So this is broken, right? NDCG is less broken. There's not nearly so much saturation, but the scores were still high. And we have to believe, so the top 10 were judged, and so we believe these NDCG scores for these runs. And so that's, as you'll see eventually, I mean, that's one solution, is just to use a better measure than precision at 10. There are two ways of looking, there are at least two ways, but these are the two ways that I have on my slide here, of looking at the quality of a collection. One is known as the leave out uniques test, or the LU test. And here, this was started way back when we were using just pooling, and the idea was we're going to try and see the quality of a collection by looking at runs that were not submitted, but of course we don't have any not submitted runs, so we pretend we have not submitted runs by leaving out of the relevance judgments those documents that only a single team submitted. That's the uniques part of that name. Okay, so only a single team submitted this set of documents. If that team hadn't participated, then we would not have known that it was a relevant document, and we could see how much scores change if with and without those documents. We can do a similar sort of test, not exactly the same, because now the concept of a uniquely retrieved relevant document is undefined in Cal. But we do a similar sort of thing, and we look at how the scores change. And that doesn't look like a big drop. So what this is, the x-axis here is NDCG 10 with all runs in the pool, and the y-axis is the NDCG score without some one team's runs in the initial depth 10 pool, with Cal then processing with those two different initial top 10 pools. There are a couple runs, and in particular this run here, when you compare their scores to other runs that were submitted, they drop like 29 places within the ranking, and 29 is a big number, right? 29 suggests that that run at least is affected by missing relevance, and that suggests that there will be other runs that we don't even have yet that we won't know, but we can suspect that there are going to be other runs that have this problem. That other one is this bootstrap stability test, is a test of if you take different topic set sizes of, you take two different samples of topic size of a given size, evaluate all the runs on those two topic sets, and compare which run is better, and you repeat that a bunch of times. How often do you get different answers to which of the pairs of runs are different? You would like that to be never. That's not true. It's almost never. But the propensity to swap, to have these swaps, changes. The smaller the difference between the runs originally, the larger the likelihood is that you'll get a swap, and that's what these different bins are. The bigger the set size, again, the less likely are you to get a swap. This particular graph here, which you can't really see, and that's the problem, is that there's two different lines for each of these, right? One line is plotted using the original collection, and the other line is plotted when we added a whole bunch more, where a whole bunch more is like 13,000 more judgments. And you'll see there's very little difference when we added these 13,000 documents. And that suggests that these tools that we have to judge the quality of a collection are also dependent upon the runs that we're able to find relevant documents. And the score saturation has broken our tools to assess the quality of the runs as well. Okay? So not only do we not know how to build collections when there are this many relevant documents, we don't know how to test the quality of the collection when there's this much relevant documents also. And that's our sad story for today. So what's the way forward? Well, one thing we can do is just declare success, right? We have retrieval systems that retrieve 10 relevant documents in the top 10. What more do we want? Let's go home and say we're done, right? That's one possible reaction. But not many people really think that retrieval systems are as best as they could be. And so we might want to try doing something else. What this little set of dots on the left here are, the darker the dot, the more we made judgments on 4 different grades. So highly relevant, very high, perfect, not relevant. The darker the dot, the more relevant the higher grade that relevance judgment was given to that document. And these are ranks from rank 1 at the bottom to rank 100 at the top. And that's across the whole set of runs. Where was the closest to 0 rank in which the document was first found? And the very top line says not relevant. That means none of the runs found it in the top 100, but the Cal process did find it. And the sad story told in that plot is that there are highly relevant documents, even some perfect documents, whose first rank at which they were retrieved was in the 90s and 80s. All right, and this again is part of our sad story, in that there's no pooling or there's no current retrieval collection building process that's going to find those documents that are that deep in the rankings, because there's just too many other relevant documents. So what's our choice? Our choice is to try and find yet more ways of sampling. Our choice could be, use a bigger budget. Our other choice could be use yet different measures, right? Ranked biased precision is a measure that will allow you to go deeper in the rankings than 10 and at least give you bounds on how many unjudged documents you've encountered, so that could at least give you the red flag when you see that those bounds are too great, that this isn't working for you. All right, and now, state of the art in collection building, it's the number of relevant that is really the problem that we have to depend on, but of course it's the number of relevant that we're trying to find that we don't know. And none of this other stuff really works as well when you have too many relevant and too big of collections. So I wanted to get to this last part of my talk, which I promised in the abstract, which is, so you want to build your own collection, right? So all these collections were for things like Trek, and where we're trying to build community resources for general purpose, lots of different measures, supports lots of different measures. You might not need that, right? So you might want to build your own retrieval collection. And so my first question to you would be, are you sure, right? Do you really want to do that? And maybe the answer is yes, but think about this. If you use an existing collection, you will have a way of knowing whether all of the different ones that all your algorithms comparison, how they compare to the state of the art, right? That can be really useful. It also saves you the problem of building your own, right? It's going to take you time and money to build your own collection. So if you can find one that matches your needs close enough, right? And remember, it doesn't have to be exactly. You can seriously consider whether there are existing collections which are a close enough match to what you need, because that in the end, that's likely to be the better choice. But okay, you've decided that no, you really need to build your own. My next question to you would be, what is your goal? Do you really want to test 2 live algorithms to see, in this very specific case, which of these 2 choices are going to be best? Then you probably don't want to build a test collection. You probably want to do A/B testing. Okay? I say, no, I can't do that. What I want to do is I want to be able to document what the current state of my system is, maybe to do further regression testing or something later on, and that's fine too. Then you better sample your current stream of queries and get a sample of your current document set and make sure that that reflects what you actually care about. And use the metrics, right? And get deep enough judgment so you can use the metrics that you care about also. But maybe you want to be doing this because one of the big things of test collections is to drive improvement. If that is what your goal is of building your own collection, you probably don't want a current sample. You probably want to oversample those hard cases, right? Because that's what you're trying to improve. And it's unlikely that your high precision measures are then going to be the correct measures to be using to drive the system improvement. Okay? And just some other considerations when you've built your collections. Remember that you're going to need additional budget to actually do some quality control. So don't spend all of your budget on getting the judgments to begin with. For ongoing use of this, beware of, and this is true for Trek too, we have to beware of an entire community overfitting to a single collection, right? Which is why we don't want to have single collections. But if you're going to build a collection and all your testing is going to be on this single collection, then your collection is you are likely to overfit to your single collection. And you also have to beware of repeated tests, the statistical problem of using repeated tests. So just be aware of that as well. So this is just sort of the summary of what I had before of, why do we want to use Cranfield? Well, it has sufficient fidelity to real users' tasks, but here it's, it's informative if the task is appropriately operationalized. It's general enough to be broadly applicable, but the feasibility and expense of that is going to depend upon the unknown number of relevant. And you lose realism to gain control, but the appropriateness of these alternatives is going to depend upon what you're trying to prove and what context you're using it in. And that's it. Thank you. Sorry, went over.
Okay, do we have questions? stunned them into
Yes.
silence. Yeah.
I can ask. Have you given thought to like it's kind of the antithesis of a collection. Like when you're not interested in the reusability or the durability, but like a disposable collection, you just need to be able to disambiguate which retrieval method is superior to the other one. Are there, like 50 topics is a common volume of things in track?
Right, okay, so the question is, what happens if you don't care about reusability or general purposeness? You just want to take these two, you have a small set of runs that you want to know which are better, and how many topics do you want to have in that case, et cetera. There's a line of research called the minimum test collection. This was done by Ben Carteret and his colleagues when he was still at UMass. And it was developed explicitly for the case where you have a small set of known runs, and all you want to do is you want to pick the smallest number of documents which will distinguish among those runs. In that particular case, they advocated for more topics, less deeply judged. There's a lot of other literature that took off from that, again suggesting, and in fact the Trec million query track was part of this whole thing, which suggested that you really, really want to use very shallow judgments on very many topics, and that's a better way of distinguishing among systems. There's been more recent research that says, wait a minute, that's true in some circumstances, but not in all circumstances. My guess is that it probably is true in circumstances where you have, where your user model is very shallow, right? I mean, so it's more like almost question answering sort of, or known item search sort of thing. And you can get, I mean, then that's because you can get judgments to that depth, and you can be pretty confident in your comparisons among systems there.
Thank you. Other questions? Check online. Great. Thank you very much.
Okay, thank you.